So good morning, everybody. Thank you for inviting me, and thank you for letting me speak about concrete roads, which is one of my favorite, I think. When I prepared this presentation, I really thought about the 100-year concrete road. What is it? Do we have it already without knowing? Or how can we get there by improving what we have? I say, do we have it already without knowing? It was this morning that I thought about it. We say we don't have 100-year-old roads, but all our concrete roads were built in the years 20, 30, 40. So they're not supposed to be already 100 years, and we still have them. So perhaps they will reach that 100 year, and we have them already without knowing, but they're not old enough. They weren't built before the years 20. So could be a reason why we don't have it yet. So we still have a theoretical design of 30 years. So the lifetime we're built for is 30 years. And that's a point which is really interesting, because what is a lifetime? An expected lifetime, a design lifetime, is the lifetime during which a certain amount of traffic will go over the pavement and there will be no degradation. There is maintenance. Maintenance, I think, is really, really important to get to that 100-year-old concrete road, or road in general. There is maintenance needed, and your type and amount of traffic is defining your total lifetime. If you have a lot of heavy traffic, you will reach that lifetime much earlier. If you have few heavy traffic, your lifetime will be extended, or your real lifetime, the years in service, will be much larger for the same structure. So always link it to your amount of traffic. At this moment, we have highways, we have local roads, we have connecting roads, which are more than 50 years, more than 70 years even. We see that in some times there are degradations coming. So the highways, I think 60 years, 70 years can be reachable, as I will show you. I will talk about CRCP, so the continuous reinforced concrete, and I will talk about GPCP, the jointed plain concrete, doweled or not doweled. Just to show you one of the nice roads we have near Ypres in Flanders. It's nice. The old one still has the date imprinted. They don't do it now anymore, but then normally you can find it back. So this one was built in May 38. So one of the examples where I say it probably will reach 100 years, but yeah, it's not old enough yet to get there. So as you can see, they're old plates, very long plates. We don't do that anymore. We make them shorter because with a lot of traffic, you will see that they will break. So the length of your slab is important there. They didn't have dowels, they didn't have tie bars, but they're still in a very good condition. Maintenance is excellent. All the joints are filled, so there's no water infiltration, which means you don't have pumping effect, so you will increase your lifetime for sure. The other one is taken from Brussels. It's in a really living center of Brussels, so with a lot of houses, not that much heavy traffic. As you can see, some grinding has been done because there was some faulting, some step formation, and with the grinding, they leveled out that, so you get a good evenness, and the comfort is increased a lot. The noise is reduced, although they're not driving very fast there, so there's very few rolling noise, but the comfort by the faulting, so the faulting's gone away, and it's very high in that case. This is one of our oldest highways we have, where concrete is still visible in some parts. You notice because it's getting louder, because they used very large aggregate at that time, so it's kind of a loud surface. But in the main parts, or the large parts, are covered with asphalt, which also increases the lifetime. So you have your traditional structure, concrete pavement. In this case, it was 20 to 23 centimeter, on an asphalt interlayer, which is kind of protecting the base layer and give a good adherence. You see it's lost there after 50 years in service, but it's still there. Then you have a good quality lean concrete. You see some erosion at the top, but it still is limited. And it's put on a very good sub-base layer. In this case, it was stabilized sand, so which is still in very good condition. It's 50 years old. It was covered in 2007 after 35 years in service because it became too loud, so it was purely comfort related. So the structure is still very good. You have 10% heavy traffic, and you have over 1 million trucks passing that highway each year. Just to be sure that everybody knows what CRCP is, CRCP, so continuous reinforced concrete, is what we are using for our highways. It has the big advantage that it doesn't have any transfer, or very few, only constructing transverse joints. So you get rid of all the maintenance of the transfer joints, you get rid of all the faulting which can appear, the dum you hear on the highways. Because even when you construct it very well, I think in Germany they have a lot of examples of GPCP on a highway, you still hear the faulting after some years. With CRCP, it's not the case. You need cracks, but the crack pattern is very homogeneous, or should be as homogeneous as possible, and your cracks are closed. The closing of your cracks is made by the reinforcement you put in, longitudinal reinforcement, which is continuously. The structural bearing capacity you get from your thickness of your concrete, which is similar as a GPCP, as a slab concrete. Just for information, the structure we used in the year 70, important here is the asphalt interlayer, I think, because it's protecting your base layer from erosion, and it gives an adherence between the pavement and the base layer, which will be lost over time, but which will give you an extra structural reinforcement, let's say, so you can have a longer service life due to the presence of that asphalt interlayer. Also, the width of the lanes is important because you want to avoid trucks driving over your longitudinal joint, as that is the weak point in your CRCP. These are some other cores taken from another highway, the left, and from the E40 at the right. And as you can see, there is some damage at the bottom of the base layer. And that's important to know, that if you have your fatigue, so if you reach your end of life of a pavement, it will start from the bottom of your base layer. And you design a pavement by stresses, concrete pavement, and the stresses are at the bottom of your concrete pavement and the bottom of your base layer. The base layer is the weak point in here. So if you can increase the durability or the longevity of your base layer, you will increase also the total structure, the lifetime of the total structure. So a good design is really important, and the design should incorporate the base layer, so the whole structure should be looked at. Also, the quality of that base layer is really important, and for that, you need to design it well and specify the materials very well. The stiffer your base layer is, the less stresses will be in your pavement, and the longer your total structure will survive. By using CRCP, you're also increasing the load transfer at your cracks in that case, or at your joints, if there's a structural joint, by adding that longitudinal reinforcement. What is also needed to get to the 100-year-old road is material design. We need to specify our materials better to be sure that you don't have corrosion of your tie bars, of your dowels, to be sure that the erosion or erodibility of your materials is as low as possible. Why is corrosion entering here? Normally we don't have a lot of problems with corrosion, but if you last 50 years, 100 years, of course, then the bars will be corroded and they will not be in service anymore. And then, of course, your load transfer is decreasing and you get very quickly to the end. Maintenance is needed, mainly towards water infiltration. We want to avoid that. I also work on water permeable pavements. That's something else. In this case, you want to avoid all water infiltration into your structure. And if you do repair, you will need some repair on some spots anyhow. That repair needs to be durable in relation to the concrete pavement. Also, driving comfort and safety needs to be taken into account because you can have some loose and skid resistance, for example. We use high quality aggregates, so we don't see any reduction in skid resistance. But if you go to the 100 year, you could think of an asphalt overlay to increase the comfort and the skid resistance again. Or you could think of grinding, as you will see later and as you will hear later today. I will not go into detail, but this is design, structural design. How do we incorporate a better design for longer lifetime? Design is a translation of your traffic you have, your different type of traffic you have, towards a thickness and a type of material. In the right figure, you see, I'll try this one. You see 3 curves. This is for GPCP, so jointed plain concrete without dowels. If you introduce dowels, you see that your lifetime or your amount of standard axles which goes over it is increasing quite a lot. This is logarithmic, so be aware this is times 100, I think, almost. If you put CRCP, you see you have 10 times more lifetime, 10 times more axles which can go over. Also, the influence of the thickness is important. The higher you go, the more you will be able to withstand, with a certain maximum, of course. At a certain point, it will not help to increase the thickness. So if we want to have more axles, if we want to reach that higher lifetime, you will need a thicker pavement, but for sure you will need also some reinforcement in it, CRCP or dowels in your jointed plain concrete. That will increase quite a lot also the lifetime. Why do I speak about heavy traffic? That's just what I want to mention here. Know that the design theory started in the States, so the impact of each axle is tested there. They had 3 different types of vehicles which they tested, and they just put them on a track where they had different types of pavements, just drove over them and saw the impact of each axle on the durability of the pavement. From that, there was a fatigue law, which you see here. What does that mean? That means that one axle of a truck, I just translate for the ones in the back, so 1 times 13-ton axle is equal, the impact of that axle is equal to 6 million cars. Which means, of course, that cars, you can forget. You need the cars to design your amount of lanes you need on your pavement, but for the structural design, you need your heavy traffic. That's the only one you really need. If you know that, it's okay. Look then at the material design. So I think there corrosion is one of the main factors we need to get rid of when we want to reach the 100 years. You can do that by better maintenance, keep the water out and your corrosion will be less. But you also need the protection of your material. What we do now is protecting the tie bars in the middle. We put an epoxy coating, which lasts much longer, and we will avoid the corrosion. We put on dowels, we put completely with a coating, just because there, of course, the widening is higher and the risk is higher to get corroded. Other solutions could be glass fiber reinforced rebars and dowels. We did some calculations now. There is a little loss in transfer possible. For the local roads, it doesn't have any influence. For highways, you have to look at it. But it's possible with the same layout almost to have them in your concrete, and of course they will not corrode over time. So I think a very good way to do. They're also better for placement, they're much lighter, so it's easier placement. And we had test sections with them and we got good results in execution, so nice material. Erodibility is also important. We see that if you increase the amount of cement, that's not something which came from me, but you see that the increase of cement will decrease the erodibility of your base layer. And that's important because this is pictures taken from course from the A17. It's between Bruges and Kortrijk, nice cities. You should visit also. Have good chocolate there, so... And in that pavement, you see the longitudinal joint is here. We took a core away from that longitudinal joint, so to the right from this one, and you see there's no erosion. So if you don't have any traffic on it, it's on the emergency lane, you don't have any erosion. This is at the right side of the longitudinal joint, and you see there the erosion is starting. And this is at the left side, and you see there you have really degradation. The base layer is not intact anymore, and you get the start of punch out, start of degradation. Why is this a problem on this highway? They economized, they left out the asphalt interlayer, they left out the protection of your base layer, and they got corrosion after 20 years, which is not the lifetime we want for CRCP. We want at least 40, 50 years. So a good design, keeping the layers you want, keeping that adhesion layer is really important, and improving the durability of your base layer is also very important to get to the 100 years. So I think with CRCP on our highways, we can reach the 100 years if we probably would increase the thickness. We could increase the reinforcement rate. You have a minimum for, at this moment, for 0.75%. For those who are in structural engineering, this is not structural reinforcement. It's way too low. It's just reinforcement to keep the cracks closed. It's placed at the top, or a bit higher than the middle of your pavement, just to be sure that the cracks are closed and that you will not have water infiltration. So increasing that could lead to longer lifetimes. Increasing the thickness for sure is needed. Quality of the base layer, presence of an asphalt interlayer, and then positioning of that longitudinal joint, because if you're driving on that, your stresses are higher, pumping effects could be introduced, so you don't want to be that. In relation to that, we avoid all longitudinal joints between concrete and asphalt, so if you have an exit and an entrance, we also put that in concrete just until they're separated, and then we go to asphalt. With CRCP, you have one main problem that are the punch outs. The moment you lose your support by your base layer, you have a risk that there are small cracks formed, and then you have a punch out. Here is a figure made by some students for me based on the MEPDG program in the States. You see an increase in thickness, an increase in reinforcement rate decreases the risk on punch out enormously. So respect the minima and go perhaps a bit further to be sure that you have the long lifetime. We also introduced active crack control to have a more homogeneous crack pattern. I can inform you on that also if you want. It's really helping to increase durability of CRCP. Going back to the GPCP and telling you why corrosion is important, this is a nice example in West Flanders also, constructed in 1958, and in 2007 they had, so 50 years in service, they started to have complaints about vibrations. So people living at the site said, okay, it's getting really bad. They did some research and they saw that all the dowels which were present at the time were corroded. So now you had a good concrete road, still very structural, very stable, but with faulting, with step formation, and with a lot of vibrations. So what did we do here? We just put new dowels in. You can see them here, 3 dowels in the driving lane. They've been put there in 2007 and they're still in very good condition. There's no faulting anymore, so it's still very, very good. It's not easy to do that, so if we could bring in dowels which last for 100 years, this road will definitely last for 100 years, especially as the thickness was larger. It was 30 centimeters because they had a lot of industrial traffic, so that will for sure last 30 years. I also talked about maintenance strategy. I think that is really important. And here again, when you see CRCP, you almost do not have maintenance. You will have some spots perhaps where you have to do something. You will need to maintain your longitudinal joints, but you don't have the transfer joints, so maintenance goes down very much. What you also see, if you don't have a replacement, if you can increase your durability of your pavement, for sure your interruption of traffic is much lower, and that will also have a positive influence on your social impact of your pavement. I just finished, or just the publication just came out. It's a publication for the German Steel Federation on the life cycle cost analysis of CRCP compared to the others. So if you are interested, I will transfer it to you, or you can have a look, and I will give it digitally also to BritPave, the link that you can have a look through the website. This is really important table. That's why I made it unreadable, but you can read it in the publication. It is, what impact do you expect from the types of pavement? So what maintenance will you have to do, and at what frequency is it there? Of course, also if you can increase that frequency, yeah, the better it is for the customer, for the user. Surface characteristics are also important. In Belgium, we did a lot of research on low noise concrete pavements. And we saw, we still see, because at the moment they are built, that the two-layered concrete pavement, so with the exposed aggregate surface at the top, is performing very well. We get noise reductions, which are, or we get the noise production, which are comparable and better than a new SMA C, so 0 to 10 millimeter split mastic asphalt overlay or top layer, which is the reference for the noise in Belgium and where we need to be around for the surface. So we see that with a two-layered CRCP, we're getting there. Even with the one-layered CRCP, we're also getting there because there's a very good evenness, which is also influencing the noise production of a surface. For the old roads, we applied next-generation concrete surface. I will not go in detail. That will be explained later today. Just know that we had a test section some 10 years ago, I think, or something of 7 years ago, 100 meter. There we kind of defined our specifications from. We had different types. One came out as very good, where we got reductions at the beginning -6, but then constantly -4, 4.5 decibel. We applied this also on the ring road in Antwerp, where you have a lot of traffic last year, and also there it's performing very well. You see really the noise reduction, which is really very important. -3 decibel means half of the noise. It's logarithmic. -4.5 is very important noise reduction. I have no idea on timing, but I want to... Okay, thank you. I just want to end by showing you some projects we're doing now in Belgium, or we did some years ago, on highways where we're using concrete pavements because we think they're very good in durability, they're low in maintenance, and they have some advantages towards other types of pavements, not to name them, for some typical applications also. So one is the A11. It's a PPP project, public-private project, where they made a choice, especially for the parts which were in tunnels and in open trenches, to use concrete there because the advantages of the light, because the advantages of low maintenance, and so all tunnels and trenches are made with a double-layered concrete road. It's in the fields. It's really in the fields, but it's a natural zone, so they didn't want the noise production to be too high. So even in the open trenches and the tunnel, they put a two-layered CRCP. This one is still just a picture, a wish. That how it would look. I can assure you it looks the same. So I didn't have the same viewpoint, so I couldn't take the picture, but it looks really the same when you drive on it. This is during construction. As you can see, the tunnel didn't mean any problems for constructing. I mean, you need to take care, of course, that you don't get the ceiling, but it's really feasible to put CRCP in that tunnel. The advantage of the tunnel, of course, is that you have a very good base. You have a concrete floor of 1 meter, so you cannot have better than that. So you can reduce the thickness of your CRCP a bit. The 50 millimeter sandwich layer you still use, and then you need a water impermeable membrane we use mainly to protect your concrete from water beneath. This is the execution. You see the two lift pavement. So we have two slip-form pavers, one after the other. Because it's CRCP, of course, you have your longitudinal reinforcement, which is continuously. So you cannot make it in one width. You need to have two faces at least, because you cannot drive on it. But with that, you can bring your concrete to both your concretes to the place where you have to pour it. You also see the space between both. We say it cannot be more than 30 minutes in between, which means more or less 30 meters. I'm sure if you go to 1 hour, it shouldn't be a problem because you have some flexibility in that, but we aim for the 30 minutes to be sure that you have a good intermingling. It's not an adherence because it's not a straight line. They just mingle one with the other, fresh in fresh you put on them. The last one is the plastic sheet and the retarder, which is sprayed on to retard the surface, to have it exposed aggregate surface after it. So here you see the finishing. Then you brush away that cement slurry at the surface, which is not hardened. After 15, 16 hours it was done in this case. And what is really important here, why I show you this is a PPP project. I've never seen it on another project, but they cleaned the asphalt because that asphalt interlayer need to be bonded with your concrete, and that will ensure the bond, that you don't have any smurry on it. So they cleaned it with the machine and then by hand in between the rebars or the tie bars which are present already. So very nice execution, very nice site. The other one I'm involved very closely. I'm working now for Lantis, which is the owner of the Oosterweel connection in Antwerp. It's a closure of the ring road around Antwerp. There it's really a sustainable approach. There has been a lot of interference, I almost want to say, with the local people, with the people living there, with all people involved in a sustainable solution. We had a bridge in 2006. Everything was signed for a bridge. And then there was that much interference of everybody, let's say, who was not Lantis at that time, that it changed to a tunnel. So now we're building a tunnel. Some 10 years later, or even more, it started. One of the demands are concrete as much as possible. It's not always possible technically, can increase the cost of the tunnel, but in most places it will be concrete. Some pictures just to show how it will change the look of Antwerp. Everything will go underground. There is a new connection under the Scheldt, so a third tunnel under the Scheldt, which will increase mobility a lot. The place which is gained by that will be rebuilt in a green area. So we will not only make the ring for traffic closed, but also for pedestrian and cyclists. Also there, the ring will be closed in a green area. This is how it is now at the Sportpaleis, which is a big event place. You have a viaduct, so it's really not a nice place. You see it there running. Lobroek Dock, which is a place which you will recognize, is this one. So this viaduct and this bridge will be gone, and we will transform it in here. So here you see the viaduct, which used to be there. It goes -2, and then the other road, connection road, will also be put into the ground. So you make a green ring above the ring for the traffic, the cars and vehicles. This is another view. You give spaces back to the people where they live. You make connections. The ring is not more disrupting the city, but it's connecting the city much more. So a very nice project. So I'm involved there for the CRCP and the asphalt. So the road specialist, let's say. But also there we want CRCP as much as possible for the low maintenance. We put even 25 centimeter in the tunnels, which make it last longer. So Some pictures of the construction. So you see the CRCP here, the reinforcement starting. We do complete width in concrete, so no emergency lanes in asphalt, because the longitudinal joint is always a problem and will give you problems over time. You also have diversions over the emergency lane, so we do really the total width in concrete. And we look at the details, because that's also a really important matter, I think. For example, the entrances and exits. So we make that there's no longitudinal joint between asphalt and concrete, especially here they're driving over it, so it's not wanted. So we do everything in concrete, and there we do the transfer to asphalt, because the ramps are mostly made in asphalt. It's not easy. I don't go in detail here, but this is an exercise we did for the left bank of the Oosterweel. We want everything to be in concrete, so it needs to fit in the width. Width is always changing because you have your curves and everything, so you need to adapt. We did the exercise, we do everything with slipform paver as much as possible, and you see only the pink small parts are made by hand. And even there, sometimes we do some machine placement, and then we cut parts away to be sure that it's good quality. So it's an exercise which is done in this case for the left bank, which will be done for the right bank. It's complete interchange, exposure even from the contractor to the owner in this case. The phasing needs to be adapted, but it's worth for the end result. It gets good quality. I cannot leave roundabouts out. For in England, I have to mention them. So also there we have very nice solutions with slabs, but also with CRCP. Roundabouts are especially tricky if they are in industrial zones. They need to have large curves, so ideal for CRCP. And in this case, your CRCP is really connected throughout, so you don't need any anchor locks at the end. It has a bit adapted reinforcement. The reinforcement rate is a bit higher when you calculate it, but we have very good schemes how to do it. And we even used it here. I love the name, dog bone roundabout. It doesn't seem like two roundabouts in CRCP, but I can assure you, here we put two roundabouts in CRCP, so they're connected throughout because of durability. It's the connection to the harbor, so really only heavy traffic. In that way, we're sure that the durability of that roundabout will be there and maintenance will be very low. Also, the entrances, I would have liked it a bit longer, but the entrances to the roundabout are made in concrete, so the exits are then almost directly in asphalt, but the entrances are also in concrete, just to be sure you don't have any rutting when heavy traffic is standing there. So I think I can conclude we are almost there. Could be that we are there without knowing, that they just will last for 100 years. But I think to be sure that we reach that 100 years, we need to adapt a bit the design. It will cost a bit more at the beginning, but over the total lifetime, the cost will for sure be lower because your maintenance go down, your reconstruction will be much longer before you need to reconstruct. Material design is really important, avoiding that corrosion. Joint layout I didn't talk about, but it's also really a part which needs to be in consideration at the design phase and needs to be reconsidered during the placement, because then, I mean, the phasing is also playing a role in that. Maintenance strategy is going for no water in the structure at all time. And then, of course, you have the quality of materials, quality of execution. With concrete, it is possible to get a sustainable pavement because you have low maintenance, low interference, because you have low noise emission. It is possible. If you don't reach it, you can go to other overlays or next generation concrete surface to reduce it again. I always thought this was kind of publicity talk, the light reflection, but we actually reduced the lighting in the tunnels in Oosterweel. So the lighting persons calculated it, and with the reflection of the concrete, it was possible to reduce the light capacity in the tunnels. And due to the low maintenance, we have high availability. So with a nice view on the two-lift pavement on the left bank, I invite you to get a look. It will last for 10 years more, the works in Antwerp, so you're always welcome to come and visit. And I thank you for your attention.